So today I'm going to talk about time series modeling, and while I'm talking about time series, I'm going to talk about what time series is, what time series decomposition is, what simple moving average is, and what weighted simple moving average is. So coming to time series data. So when you're working upon time series data, basically it's a temporal data where you have all the data points, but the data points also have a timestamp along with it. So it's a compulsion for a time series data set to have a timestamp. That's how you analyze on it, because you're doing a time series analysis. So for example, you can have say a sales of a company. It can either be quarterly, it can be monthly, it can be yearly, or it could also be daily. And using this data, we can what we do to visualize this data is we create a line graph. So in line graph, you can see, for example, on the x-axis you can have the sales, the products, and on the y-axis you can have the time, either quarterly, yearly, etc. So what you can do with this type of data is you can do two things. You can do time series analysis and you can do time series forecasting. So for time series analysis, you basically plot the data and you try and find trends and what is giving you more sales, or what product is giving you more profit over what time, etc. You can also use this for forecasting. When I say forecasting, you can have historical data, and over that historical data you can predict future values. For example, weather forecasting, astronomy, the places of the orbital place of planets, and say earthquake forecasting, or any disastrous forecasting, or any type of forecasting that you want to do. You can also, the forecasting is not limited to natural disasters. You can also forecast this product will give you this much sales. So again I repeat that time series data has to have two things compulsory. One is the date and one is the dependent variable, because if these two things are not there, you cannot run any analysis or forecasting on the data. Well, now we'll talk about time series decomposition. So there are four things you need to keep in mind when you do this. The first thing is cyclic, second thing is seasonal, third thing is random, and the fourth thing is trend. So when you plot the graph of time series data, you will basically get a line graph, and if you do it say yearly, then you will get year 1 this graph, year 2 the other graph. So you have to compare this year, second year, third year, fourth year, and you can find out different things. So the first thing what I'd like to talk about is random. Random data is also known as white noise, and you cannot do any type of analysis and forecasting on that type of data. It is not possible. And the data set with a lot of white noise is not a good data set. So you have to minimize the white noise or the random data in the data set. What about trend? So basically, for example, you have an upward going graph or a downward going graph. So basically that is a trend. Your data is giving you an upward trend, or it's giving you a downward trend. So you can see what kind of trend it is. The second thing is cyclic. So for example, if you do a time series analysis on quarterly sales, right? So for example, it gives you a heartbeat type of graph, and if it's repeating it every quarter, you can say that it's a cyclic graph. For example, for May, from Jan to Feb, it's giving you, for every year it's giving you an upward graph or the same heartbeat graph. So, or you can also compare in the same year, if from Jan to Feb, or the first quarter, second quarter, third quarter are giving you same type of line graph, then it means that it is cyclic. What about seasonal? So basically in India, when you talk about India, seasonal is basically, you can talk about seasonal fruits. The sales of seasonal fruits like mangoes will be more during April to May or April to June. And this will be the same for every year, because it's a seasonal trend. You can also and seasonal trends can be, seasonal data can be found out in the same data set. Even if you do it for one, if you have it for cyclic, you can find cyclic trends in 1 year. But for seasonal, you need to have different years of data so that you know that it's a seasonal trend for mangoes, or for sales of firecrackers. It will be more during the Diwali season. So that is when the sales will be the highest every year. So that is what the seasonal trend is. So these are the four things we spoke about in time series decomposition. So now the next thing we'll talk about is moving average. simple moving average and weighted moving average. So for example, you have a data set, and so first we'll talk about simple moving average. In simple moving average, the first thing you do is you give it a window, a time window. For example, I take a time window of 3 months. So now I have data of say 12 months, and I need to find the simple moving average of the entire year. So the first two values, say Jan and Feb, are for example 0 and 0, and I want to find the simple moving average for March, for the third month. So what I'll do is, and the time window, what I said before, it's 3 months. So you do not take an entire mean of the entire 12 months and then give a mean saying that this is a mean of your sales. You can't do that because that will be incorrect. What you have to do is you take every 3 months, and every 3 months, when I say that, the first 3 months, the third month's average will be first month, second month, first month, second month, and third one. That will be the simple moving average for the third month. For the fourth month, it will be second month, third month, and fourth month, and so on. This is so that your data, the mean that you calculate is appropriate. Because for example, if you take into consideration historical data of say past 50 years, and you want to analyze the data of the current year, or maybe the future prediction that you want to do. So in simple moving average, we do not give as much importance to the historical data. What we do is we don't give as much importance, as we don't exclude it from anything. It's there, the data is there, but what we do is the recent data carries more weightage in our case, in simple moving average. So to get the mean around there, we do not consider historical data as much, because we want recent trends and etc. So in simple moving average, you do that. Now we come to weighted moving average. It is similar to simple moving average, but what we do is we have historical data of say past 50 years, and we have current data of the current year. We assign priorities. By priorities I mean weights. So to get, and the process the algorithm we use in this is known as exponential smoothing. So what you do is you assign priority to your previous years and the current years. So the priority of your historical data will be less, and the priority of your current data will be more. This is how you balance out the weight. So for example, in this case you take into consideration the historical data, but the weight you assign it is comparatively less to what the weight you assign to your recent data. So that balances out the mean, and this is known as weighted moving average, and you use exponential smoothing to do so. That's it.